Hey y'all, welcome back. So today we are solving some problems that involve polar equations. So this first one says the graphs of r equals 2, which is this circle right here, and r equals 3 plus 2 cosine theta are shown at the right. Okay, so this lima bean looking graph is the 3 plus 2 cosine theta, and we're looking for the x and y coordinates of the intersection points of the two graphs. So we are looking for, let's see here, this point and this point. So the strategy here is first we're going to set the two equations equal to each other, this one and this one. So we'll get 2 plus, or equals 3 plus 2 cosine theta. And we'll go through the normal steps to solve this. So we'll subtract 3 from both sides. And then we'll divide both sides by 2. So what we get is negative 1/2 equals cosine x, or cosine theta. And so to solve this, what we need to do is look on the unit circle for where cosine is equal to 1/2. So let's pull that up. So we can see there's going to be two places where this happens, at 2 pi over 3 and 4 pi over 3. Let me make this a little smaller so you can see it. There we go. So theta can either equal 2 pi over 3 or theta can equal 4 pi over 3. And so what these two represent are the angle measures, or the terminal sides of the angle measures where the intersection falls. So in other words, like this angle right here is the 2 pi over 3, and this angle right here is the 4 pi over 3. Okay, so the next thing to do is figure out the r value, which is actually given. We don't have to do any solving or anything. They give us the r value right here. So we know r is 2. So the two coordinates in polar form will be 2 comma 2 pi over 3. And 2 comma 4 pi over 3. So for each one of these, we'll need to convert to x and y. So just as a little reminder, x is r cosine theta, and y is r sine theta. So these are the conversion equations we'll use to calculate x and y. So we'll have to do this for each point. You know what? I might just do this separately. Okay, so for the first one, we'll have 2 times the cosine of 2 pi over 3 for x. Now the cosine of 2 pi over 3, if we bring up that unit circle, we can see that it is negative 1/2, which is basically what we're expecting, right? We're trying to find where these are negative 1/2. So we know what that value should be. So that'll be the x for the first one, and 2 times negative 1/2 is negative 1. So the next thing we'll do is calculate y. So the y will be 2 times the sine of 2 pi over 3, and the sine of 2 pi over 3 is root 3 over 2. Two times root 3 over 2 is just going to be root 3. Oops. All right, so now we got our x and y for the first coordinate. So the coordinate in rectangular form, because it is asking us for it in xy, is going to be negative 1, comma, root 3. And this point will be the one that is right here. Oops. Guess I could just put it over here. Okay, so there's the first one. And then the second one, we'll basically solve it the same way, except we'll be dealing with 4 pi over 3 instead of 2 pi over 3. So that's really the only change here. And then when we go to evaluate these trig functions, we'll get a slightly different answer. Okay, so for this next one, we'll have 2 times the cosine of 4 pi over 3 and 2 times the sine of 4 pi over 3. The cosine of 4 pi over 3 should be the same thing. None of this should change because we know what the cosine of theta should be for both of these. So for the sine, though, we should get negative root 3 over 2. So that our y value will actually be negative root 3. All right, so this coordinate is going to be the other one. All right, so that is number 1. We got negative 1 root 3 is this intersection point, and negative 1 negative root 3 is this intersection point. Okay, let's take a look at number 2. So for number 2, it says the graphs, we've got 2 equations here, are graphed on the interval between 0 and pi. Okay, so just to kind of give you a visual, the only part of the graph is when theta is going to be in between 0 and pi. That doesn't necessarily mean that we can't have points down here, because we could potentially have negative r values. But it doesn't look like, I mean, since all these are positive, it's not going to be negative anyway. So yeah, we are going to be limited to these 2 quadrants. Anyway, we want to know for what value of theta do these curves intersect. So let's go ahead and set them equal to each other. So this r equals 3 theta squared plus theta is going to be equal to 2. And we're just solving for theta here. I mean, so really this is just like a algebra 1 quadratic solving kind of a problem. We're going to set it equal to 0. So 3 theta squared plus theta minus 2 equals 0. So this is kind of like solving an equation like 3x squared plus x minus 2. It's just instead of x, we've got theta here. So the way to solve a quadratic is either using the quadratic formula, or we can factor, if we can factor. Factoring is definitely the way to go, and the factors in this case would be 3 theta minus 2 and theta plus 1. So now we need to set each one of these equal to 0. We're going to use the zero product property that states when you have two things that multiply to give you 0, at least one of them's got to be 0. So for the first one, we would add 2, divide by 3. So we'd get theta equals 2/3. And for the second one, we would get theta equals, we'd subtract 1 from both sides, so we get -1. Now, both of these would be solutions to this equation. However, it does say that we are only graphing them on the interval between 0 and pi, so this solution is not in that interval, okay? -1 is not between 0 and about 3.14, so this one we're not going to include, okay? But so the only solution we will have here is 2/3, and that's it. So 2/3 of a radian, which would be like roughly 40-something degrees, something like that. Okay, well, there's number 2. Let's take a look at number 3. So for number 3, it's kind of the same question as number 2, where we're trying to find the theta value, where these two are going to intersect. But what's a little bit more challenging about this one is that we don't really have a good way to solve this. You know, you could try to multiply cosine over, but there's not going to be a good way to convert everything here. It's really going to be too complicated to solve algebraically. So if it's not as simple as, like, you know, solving a quadratic or something like that, then we're going to use a calculator to do this. So let me show you exactly how this would work. So let me pull up the calculator. In fact, let's pull up the entire calculator so you can see what buttons I'm pressing. How am I going to do that? Here we go. All right, so first let me kind of show you what we're dealing with here. If I go to mode, I've got some options on this third one, or fourth one, as far as how I want to input my equations. So FUNC stands for function mode. PAR stands for parametric mode, which we don't really know anything about yet. The one we really want is this POL, which stands for polar mode. So if I change it to polar mode here and go to y equals, you can see they're all in terms of r equals now. So I can type in these equations that I've got over here. And what I want to do is type, let me move this over so you can see them. Type in the first one into R1 and the second one into R2. So 4 minus 2 sine theta squared. And then the next one would be -1 divided by cosine theta. So notice when I hit this x comma t comma theta comma n, the button you normally type in for x, it puts in a theta there. Now I want to adjust my window settings here. That all looks fine. So there's the first one, kind of a weird looking graph, and then we got this second one, which is also kind of weird. We know that this is going to be a vertical line when where x is -1, right? So what we're looking for are these two intersection points here and here. Now in function mode, we could just simply go to second calc and pick the function, pick the intersection function, but that is not going to be available to us in polar mode. So we have to do something a little different to find those points of intersection. So this is going to be a little weird, but it does work. So let's go back to function mode, where if we type in the y equals button, we can type in rectangular equations. And what I'm going to do is actually type in the equations here, which is going to be a little weird, but this will actually work. So Let me actually spell out the steps here so that when you're looking back at this, you can see what we need to do. So first, we want to go to function mode. This is the default mode. So if you don't change anything, it should already be in function mode. Okay, so the next thing you want to do is you're going to type both equations into y1 and y2. All right, so let's go ahead and do that. So we've got 4 minus sine of theta squared. Now it's going to show up as an x, but that's okay. And then negative, make a little fraction here. I'm just typing these in exactly how they look, except it's going to give me, I'm typing in x instead of theta. Okay, so now what we have when we look at the graph is it's going to look pretty crazy, to be quite honest. But you got to remember that we're using the rectangular mode, the function mode, to graph these polar equations. So this is not really like the graph in polar form of what these look like. But what's interesting is that the intersection points are going to be the same. So like what we're typing in as x here is really theta, and the y is really r. So when I look at that graph, and if I find the intersection point, like right here, for instance, if I find the intersection here, the x will be my theta, and the y will be my r. So you can see there's going to be a lot of intersection points here. You know, they kind of, each one of these secant curves is going to hit the graph twice. So there's a lot of them. But the question is only asking for theta values between 1 and 2. So in my calculator, I will go to Window and change my x min and max to 1 to 2 so that I'm only seeing the part that I really want. So that's going to be that first one. Here's the second one. Looks like right there, boom. That's where my intersection is going to be. Okay, remember the x value is going to be theta and the y value is going to be r. So to find that point of intersection, you're going to hit second, calc, and to get calc, you hit the trace button. Intersection, and then you just hit enter 3 times. Okay, so let's do those series of button presses. So second, calc, go down to intersection, and then just hit enter 3 times. 1, 2, 3. No sign change. Let's try that again. Let's make sure we're over here. There we go. There we go. Okay, yeah, you might need to make sure that you're on this curve over here. So this coordinate is really your theta and your r value. So the theta value is going to be approximately 1.814. So a little under 2 radians. I might even include the units here, might be a good idea. One other thing I want to just make a note here is that, you know, when you're looking for it, you're looking at the x value. The x value is actually theta. All right, well, there's number 3. A little bit of a calculator problem there. Let's take a look at number 4. Oh. Okay, number 4. Looks like number 4 is a two-parter. Let's get rid of this calculator for right now. Okay, it says the graphs of two functions f and g are shown below. Use a calculator to find the values of theta for where f is greater than g. We'll talk about exactly what that means over the interval 0 to pi. So first things first, we need to make sure we know which one's f and which one's g. So what I'm going to do is put one of them in the calculator and just see which graph it turns out to be. So let me pull up the calculator. Now we want to go back to polar mode. So I hit mode, polar, otherwise the graph won't look right. Excuse me. I'm going to go to my r equals, which is hidden under y equals, and I'm just going to type the first one in. And basically, if I get a circle like I have in the graph there, then I know it's that one. And if it's something else, then I know it's that other little hilly-looking graph. So 2 sine theta. Let's put my window back to default here. So zoom, standard. All right, so it looks like that one is going to be the circle. If I want it to look a lot more like what I see on the worksheet, I can change the window to match that. So like it looks like the window is going from, oh, well, this is going to be a little tricky. We don't want to change the theta, we want to change x. -4 to 4, and then it looks like the y values go from -1 to a little bit above 2, so we'll just take it to 3. Okay, so it's a little skewed, but that is basically what we have here. So basically what I wanted to do is verify which one of these curves was which one, but now I know that the first one is, I'm sorry, the first one, but the f is the circle. So I'm just going to make a little note that this is f of theta. I'll just call it f. And then this other one is going to be g. Okay, so what we're doing is we're trying to find the angle measures where f is greater than g. So what I want to do is kind of explain what that means. When you plot points, you start at 0 radians, and then you kind of go around and plot points as you go. So the r value, which would be the output of the function, is the distance from the pole or from the origin to the point on the graph. So let's say we're right here, whatever angle that is. It looks like maybe like 30, 40 degrees. The point on curve G is further away from the pole than the point on F. So if this is the r value for F, and this is the r value for G, what this tells me is that G is greater than F at that angle measure. So in other words, if the point is further away from the pole, then the r value will be greater. So if we're trying to like visualize where our answers will be, we want to know where is F further away from the pole than G. So starting here, G is further away until we hit the point of intersection to where both points are exactly the same distance away. But then after that, F is further away than G. So starting from here and then going all the way around until we get to the next intersection, from here to here, F is going to be greater than G. Okay, so maybe I'll make a note. F is greater than G between the angles. Okay, or between how do I want to say this? Between the terminal sides, or I'll say between the intersections. So if we were to find the theta value of this intersection and this intersection, we could say that our solution set would be like in here, basically. So if we know, like, let's just say for argument's sake that this is 1 radians and 2 radians, okay? They're obviously not 1 and 2, but let's just say that that's 1 radian, 2 radians. then we would say that the solution set would be in between 1 and 2. So the trick here is going to be to locate these two theta values. And we will use the calculator to do that. We'll solve it exactly like we did the last one. Okay, so let's figure out where these would be. Let's go to the calculator. I'm going to go back to function mode so that I can take advantage of that intersection function. And I can clear all this out and type in the two equations I have. The first one being 2 sine theta, and the second one being theta. Oops. Here we go. Theta minus pi over 2 squared plus 1. Now the intersection, I know, I'm only plotting this between 0 and pi. That interval is given to me right here. So I can change my window to be between 0 and pi just so that that's all I really need to look at anyway. So I'm going to go to window, I'm going to change my x max to 0, my x min to 0, and my x max to pi. So when I look at the graph, I'm expecting there to be two intersections here. So there's the first one, and there's the second one. So as long as I can find the theta value of these two intersections, though they will correspond to the two intersections over here. And remember that the x value is actually theta here. So I will use the intersection function here, second calc, go down to intersect, hit enter, 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 enter. This is only going to give me one of them. This one's giving me this one right here, which is about 0.856. So theta value here, let's make a little note here, is approximately 0.856. Okay, and then my theta value over here, I need to figure out that one too. Now you could go through this intersection function again, or you could just subtract this from pi, right? Because this angle measure right here and this one are congruent. So if I take pi minus what I get over here, that should give me the other angle measure. And it looks like it's going to be like, let's see, like 2 point something. So if I get something like 2 point something, I should be pretty confident that that's right. So I'll say pi, minus the 0.856. And I do get 2 point something. Okay, good. So theta over here is approximately 2.285. All right, so between these two angle measures, F is greater than G because F is further away. Just to reiterate, the fact that F is bigger than G is really just saying that the points on F are further away from the pole than the points on G, which is happening in this angle measure here. Over here or over here, G is further away, so G is greater. So we really just want the angle measures in between here. So if we want to just go ahead and write our final answer, I would say F is greater than G when theta is in between those two angle measures, 0.856 and 2.285. So not a lot of me writing stuff down. This is a very conceptual question here. You've got to really understand first what it means for F to be greater than G, and then you have to understand how to find these points of intersection. I guess that's it. Now part B is solved basically the same way. Let me move the calculator over here. We're still basically solving the same question. When is f greater than g? But first, let's figure out which one is f, which one is g. So I'll just type in one of them. Make sure you're in polar mode so that the graph looks correct. So I'm going to go to mode, change back to polar mode, and go to r equals, delete that, and I've got 2 minus cosine theta. So I guess the question is this going to be a circle, like that top half of the circle, or is it going to be that peanut looking graph? Let's see. I'm going to have to change my window here. So it looks like this one goes from -1 to 3, so -3 to 1. Oops. Okay, so yeah, so that top half of the graph, top half, it looks like it's a circle or maybe an oval or something. Pretty sure it's a circle actually. Is going to be that first one. So I'm going to just label that so I can keep track of it. That this is F, and this peanut looking one is G. Okay, the importance here is that because we need to decide when is F greater than G. So imagine you are a terminal side of an angle measure and you're just kind of like going around like this. So starting at 0, F is greater than G here. The circle is further away from the pole than the peanut. But once I hit this intersection, the peanut, or graph G, becomes greater until I get to this intersection and then F takes over again. So we're going to say, it's almost like we're going to have two intervals here where F is greater than G. Between here and here, F is greater than G. But then also between here and here. So the solution, there's going to be two sets of solutions here. Between here and here, and between here and here. Okay. How might I make this a little bit more obvious? Maybe I'll use a different color. But basically, we're looking for this angle measure and this set of angle measures. Okay, so some of these, two of these are going to be obvious. Okay, so I'm going to say, I'm just going to copy this and say that F is greater than G when, and I'm going to have two sets of answers here. I'm going to have one that starts at 0. So it'll be from 0 to something, right? That'll be from here to up here, here to here, right? Here's 0. In fact, let me go ahead and label that theta equals 0, just so everything is as clear as possible. So yeah, here's where theta is 0. And then this angle measure is pretty clear. That should be pi. Theta is pi. So my second interval will end at pi. I'll say between 0, and actually that should be greater than or equal to 0, because it is actually greater than at 0. So we'll say or when theta is in between whatever that next angle measure is and pi. And the pi should be included as well. So you basically have two question marks here we got to fill in. We got to figure out where is this angle measure, and we got to figure out where is this angle measure. So we're going to use the same steps that we did in the last one, although we will have to find these separately because this is not symmetrical like the last one was. So the last one we just subtracted from pi to get the other one. Well, here we'll actually have to find both intersections. So I'm going to go back to my calculator, hit y equals. Oh, actually, nope, I got to go back to function mode and then go to y equals. And I'm going to type these two equations in. Let's just clear out what's there right now so nothing gets messed up. 2 minus cosine of theta. And 4 pi, so, 4 theta, so 4x, let's just do a fraction here. Don't want to leave any room for error. 4x, or 4 theta over 5, plus 2 sine, not 2 sine, but sine 2 theta. And then as far as my window goes, I'm checking between 0 and pi, but I can see clearly that the solutions are going to be between 0 and pi over 2. So just, to make things easier, let's just go 0 to pi over 2 here. You could do 0 to pi. It's just going to make the intersections a lot closer together. So let's take a look at this graph. Let's see if we can see it. If not, we can adjust the window. We're expecting two solutions. So there's one. Is it going to cross back over? Yep, there it is. Those are going to be the two that we're looking for. So remember that x here is representing theta. So what we need to do is find the two intersections. So let's find the first one. We'll do second calc. Find the intersection. Enter, enter, enter. See which one it's going to get for us. Looks like it got us the first one. So this first intersection is happening at approximately what's going on here? Why is this not? I don't know what happened there. Theta is approximately 0.424. And the other intersection is going to be over here. So we just have to be a little careful when we go through the intersect and we hit enter, enter. Make sure the guess is closer to that other one. So I'm just going to scroll over here until I get a little bit closer to that intersection. You don't have to be right on it, but just make sure you're as close as possible. And then, okay, there's the next one, 1.19. We get 1.199. Okay, now in the first one, I guess I can hide this calculator, we're pretty much done with that. In the first one, we said that f was greater than g between the intersections. But here it is different, right? F is greater than g, not in between the intersections, but on the outside of the intersections. How do I want to say that? I'll just say f is greater than g. And this is just a note, so when you go back and look at this, it kind of makes more sense. F is greater than g, not between the intersections. So in these other two intervals, between 0 and 0.424, and between 1.199 and pi. All right, now I know this is pretty complicated, y'all. I'm not gonna lie. You really got to pay attention to what you're doing here. But yeah, we do have two intervals here. We've got this interval right here, and then we've got this interval right here. And in both of those intervals, f is greater than g. So just remember that f being greater than g just means that the points on f are further away from the pole than the points at g. Whew, all right, that was a long one. There's number 4. Let's take a look at number 5. All right, number 5 is a problem off the 2003 BC Calculus AP exam. So this is kind of what you can expect to see in terms of the difficulty level on the Calculus AP test. Now, there's nothing that we haven't gone over that you need for this, so you should be able to solve this one. So let's go through it. So it says that we've got two graphs. We've got the graph of x equals 5/3 y, which has got to be this linear one. Oops. And then we've also got this square root function, x equals the square root of 1 plus y. So like, it doesn't really matter, but this is the linear one, obviously, and this other one is going to be the square root one. So it says find the polar coordinates of point P. So what we're going to do is we're going to find where these two curves intersect, and since these equations are given in rectangular form, we will find the point in rectangular form, and then we'll just simply convert it like we did on the first day of this unit, where we just converted coordinates from rectangular to polar form. So what we can do, since both of these are solved for x, is we can just set them equal to each other. And so we'll get 5/3 y equals the square root of 1 plus y squared. Okay, so next we need to square both sides. All right, we need to square this side, and we need to square this side, and really that's trying to get rid of that square root there. So we get 10/9, because, oh wait, 5 squared is not 10. Wow, that's a close one. 5 squared is 25, and 3 squared is 9, and then y squared is just y squared, equals 1 plus y squared. Squaring the square root just basically eliminates the square root. Everything underneath will stay the same. Okay, so from here, we need to combine like terms. So I'm going to subtract y squared from both sides. So 25/9 minus 1, 1 being like 9/9, would be 16/9 y squared equals 1. Okay, then I can multiply by 9 and divide by 16, or I could just multiply both sides by 9/16. Either way, I'm going to get y squared equals 9/16. Then I'm going to take the square root of both sides, and I get y equals, algebraically, I would get plus or minus 3/4. But if I'm looking at my curve, I can see that I'm in the first quadrant, so my y value has to be positive. So my y value here is going to be 3/4. Now I can use that to find x, because x is 5/3 y. So I can plug that back in and say, okay, well, if I know that y is 3/4, I can say that x is going to be 5/3 times 3/4, which would be 15/12. And actually that reduces, actually check this out, like the 3's are going to cancel out. These are both divisible by 3, so this is going to be 5/4. Okay, maybe I'll write that on a separate line here, x equals 5/4. So I've got my x and I got my y. So the coordinate of this point, at least in rectangular form, is going to be 5/4, comma, 3/4. What I need to do next is convert that to polar form, because it's saying find the polar coordinates. So to find the polar coordinates, I'm going to use those polar conversion equations. R squared equals x squared plus y squared. Let me just make a little, whoa. Getting crazy here. Okay, so r squared equals the square root, or r equals the square root of x squared plus y squared. So I'm going to have 5/4 squared plus 3/4 squared. And honestly, like, this is something you probably want to use and put in the calculator. I would put just what's underneath the square root first, just in case it's not a perfect square. I don't think it's going to be. Because, let's see, we got 5 squared is 25, 3 squared is 9, so that would be 25 and 9 would be, what would that be? 25 and 9. Okay, I'm getting out the calculator. I'm trying to do too much in my head here. Kind of lame, but whatever. Okay, so yeah, I'm just going to put in what I have here, 5/4. Anytime you're dealing with a bunch of arithmetic with fractions, you're probably better off just using the calculator anyway. That way you can avoid these mistakes, yes. Let me move the calculator over a little bit. Okay, so anyway, we've got 5/4 squared. Let's just start that over. So 5/4 squared. Oh, come on. There we go. Plus 3/4 squared. So that's 17/8. That's not, neither one of those is a perfect square, so we're just going to leave it as root 17/8. Honestly, I don't even really care so much about rationalizing or anything like that, and neither are the graders of the AP test, unless it says specifically. So we're just going to say that that's my R value, and then define theta. Now, we're in quadrant 1, so luckily our reference angle is going to be our angle. So let me hide the calculator momentarily here. So what I'm saying is this angle right here, theta is our reference angle. So we don't have to worry about adding pi or adding 2 pi or anything like that. We can just say that theta is going to equal the inverse tangent of y over x, which would be 3/4 over 5/4. Okay, this is something that, again, you're probably going to just want to put in the calculator. So let's bring that calculator back. And this one we're just going to estimate. We're going to say the inverse tangent of 3/4. I guess I need to embed some fractions in here. So 3/4 over, nope. Okay, here we go. 3/4 over 5/4. And we get about 0.54. So theta is approximately 0.540. All right, so we've got our R and our theta, so we are just about good to go here. We'll say that our final answer, remember we're trying to get the polar coordinates, so we need R and theta, and we have them. So we're going to say that our intersection point is occurring at root 17/8, comma 0.540. And that's our final answer for number 5. Okay, let's take a look at number 6. Now, number 6 is going to be one where we don't actually need a calculator to solve this one. What we're going to do here, if you can just like set the two equations equal to each other and solve, that, it's way easier to just go ahead and do that, rather than if you cannot solve the equation like we did in 3 or 4, where we had to use the calculator to find the intersection. Now, that still will work, but I'm telling you, it's way easier to do it manually than going through all those calculator steps. So let's do that for number 6. So we've got cosine squared theta equals 3/4. We need to take the square root of both sides. So your cosine theta equals plus or minus. The square root of 3 is just that, it's root 3. And the square root of 4 is 2. So we get plus or minus root 3 over 2. I'm going to pull up my unit circle. Let's get rid of this calculator. We don't need that anymore. And we're looking for angle measures where cosine is either positive or negative root 3 over 2. So we can see we've got one at pi over 6, 5 pi over 6, all the pi over 6s essentially. And so those are going to be our solutions. So we've got pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. That's it. Those are, you can see it's way easier than having to go through all that other stuff. I just realized I've got a renegade theta in here. I don't know why that's in there. Yeah, okay, well, there's number 6. Let's take a look at number 7. Ooh, we've got another calculus AP problem, so I hope you guys are ready for that. Okay, so let's do this. All right, this one says that a polar curve is given by this equation. So you've got some function, and in between pi over 2 and pi, so that would be in quadrant 2. Let me make a note here that this is talking about quadrant 2. There's a point P on the polar curve where the x-coordinate is -3. Find the angle that corresponds to P, and then find the y-coordinate of P. So let's first find the angle measure. So we want to know where this intersects with -3. Now, one thing to remember is that x is our cosine theta. Okay, so we're going to start, though, with the equation that's given. R equals 3 theta plus sine theta. Now, we know that the x-coordinate is -3, but unfortunately, we don't have how do I want to say, we don't have an r cosine theta in here. But what we could do is we could multiply both sides by cosine theta so I could convert this to x. Okay, so I'm just going to make a little note here that what I'm going to do is I'm going to multiply both sides by cosine theta. I wonder if I could just copy that and paste it. Is it going to like that? You know what? I think I've tried that before and it didn't work. But I can grab it from somewhere else here. Okay, so we're going to multiply both sides by cosine theta. And what that gives me is r cosine theta equals, and then this entire expression. So 3 theta plus sine theta, that whole side times cosine theta. Now the reason I'm doing that is because now I have r cosine theta, which I know the value of that, right? I know the x-coordinate is -3, and I know that r cosine theta is simply x. So I can make that replacement and say that -3 equals all this stuff on the right-hand side. And then we'll use a calculator to solve this, okay? So use a calculator. Use the calculator's intersect function to solve for theta. All right, so the x-coordinate was -3. That's how we got from here to here. We multiplied both sides by cosine theta because r cosine theta equals x. Okay. All right, so yeah, so now we need to pull out the calculator and actually find this intersection. All right, so let's do this. We're going to go back to function mode. Okay, we're already there. And I'm going to type in, -3. Let's clear that out. -3. And then the other side is 3 theta plus sine theta times cosine theta. And we'll be looking for the intersection. It looks like between pi over 2 and pi. So my window, I'm going to go from pi over 2 And this is pi. All right, so let's just look at the graph real quick, make sure we can see the intersection. You know what, I might have to adjust my y values, which are really my r values here. Yeah, I'm going to have to adjust. So let's bring this out a little bit and go from maybe -5 to 5 and see if we see it there. Might have to adjust a little further. Oh yeah, because there's the -3, so we should see it. So you can see the -3 right here, and then the other curve is right here. So we see the intersection occurring right here. So we'll do second calc, intersect. Enter, enter, enter. Should give us right there, and here is the theta. Okay, so I'm going to write that down. The theta is approximately 2.017. And then we can use that to find y, because y is r sine theta. So yeah, we've got, so now we can find r using the equation that we have. R equal, well, I already got it written up here. And then in each instance of theta here, I'm going to plug in 2.017. Okay, so we'll plug this into the calculator.
Not since 11 minutes ago. Oh my god.
So the R is going to be 3 times 2.017 plus sine of 2.017. All right, so we get this 6.953. So that's R. And we also know that y is r sine theta. And now we have both r and sine, and theta. So y is going to equal the r, which we just found right here. So 6.953 times the sine of 2.017. And let's type that in, we'll have our y value.
Have you started essays or anything or applications?
Where'd my calculator go? There it is.
Oh, yeah, yeah.
All right, so we get about 6.27. There we go. Now we found the y coordinate of P. We could find the x coordinate similarly, but it doesn't ask for it. So that's it. I think that's the last problem. So that's it. Y'all have a great day, and as always, let me know if you guys have any questions. Other than that, I'll see you next time.